Good afternoon, students. Today we will be studying about the different type of channels that are being used in information technology. So earlier we have studied about channels. We already know what do we mean by channel. So channel is the medium that is used between transmitter and receiver. Whenever we want to send any data from transmitter to receiver, we will use some channel. Channel is basically a medium that is used between transmitter and receiver. There are many types of channels. It can be a wireless channel, it can be a wired channel. So today we will be discussing about the different types of channels that are available in our communication system as per information theory. So we will be discussing about 4 types of channels. There are 4 types of channels that we will discuss today. The first one is deterministic channel. The second one is noiseless channel. The third one is BSC, that is binary symmetry channel. And the fourth one is lossless channel. So as per communication theory, information theory, now we will be studying about 4 different type of channels. We will study their properties and we will understand the channel capacity each type of channel is capable of handling. So as we earlier know that the capacity of any channel that is equal to maximum mutual information, and we already know that mutual information is equal to hx minus hx slash y, where hx stands for source entropy and hx slash y is equal to conditional entropy. We can also write down mutual information as hy minus hy slash x when seen from receiver side. This is the entropy, this is the mutual information when seen from receiver side. So first of all, we will find out the channel capacity of each of this channel. That what is the channel capacity of deterministic channel? What is the channel capacity of noiseless channel? We will try to find out the channel capacity of all types of channels. But the main channel that is of prime importance is BSC, the most important channel that is used in the field of communication, that is BSC, means binary symmetry channel. This is the one of the most important channel that is being used in the field of communication and information theory. So without wasting any time, now we will start with the deterministic channel. We will first of all understand the properties of deterministic channel and then we will find out its channel capacity. So what do we mean by deterministic channel? Deterministic channel. Each channel is having some channel matrix. How do we distinguish any channel? That is with the help of channel matrix. So now what do we mean by? So we will see the channel matrix for deterministic channel. We will see the channel matrix of deterministic channel. So channel matrix is also represented by py slash x. It is also written as py slash x. And in case of deterministic channel, its channel matrix is 1. Let us say this is just an example. I have written down like this is the channel matrix for deterministic channel. So you must be able to see that in this case each row there is only one element active. There is only one element active and its value is 1. So what do we mean by deterministic channels? Rows here represent inputs. Rows represents inputs and column represents outputs. So if we will draw the deterministic channel, it will appear something like this, that there are 5 inputs because there are 5 rows: x1, x2, x3, x4, x5. So there are 5 inputs and 3 outputs. So this channel will look like this. We will have 5 inputs and we will have 3 outputs, y1, y2 and y3, and it says py/x. Channel matrix means py/x. That means the probability of receiving y when x has already been transmitted. X has already been transmitted, and what is the probability that we will reach y1? That is 1. This first one means p y1/x1. That means the probability of receiving y1 when x1 has been transmitted, and this is equal to 1. Now what does this 0 stands for? 0 stands for p y2/x1, because this is the second column. Second column means y2, and second and first row. First row means x1. So this is the probability of getting y2 probability when x1 has been transmitted. X1 has been transmitted and we will get y2 at the output. This probability is 0 here. So we need not draw any line between x1 and y2. Similarly, this third zero, this represents probability of receiving y3 when x1 has been transmitted. The probability of receiving y3 when x1 has been transmitted, and this is also 0. So we need not draw any line between x1 and y3. So I have not drawn any line between x1 and y3. Now we will move on to the next row. This one represents probability of receiving y1 when x2 has been transmitted. So the probability of receiving y1, this one, first output y1 when x2 has been transmitted is 1. That means 100%. That means 100%. So we will be receiving y1 when x2 has been transmitted. This 0 will represent p y2/x2. That means probability of receiving y2 when x2 has been transmitted. Probability of receiving y2 when x2 has been transmitted is 0. So we will not draw any line between x2 and y2. This next 0 will represent probability of receiving y3 when x2 has been transmitted. x2 has been transmitted, and what are the chances that we will get y3? This is also 0. So we will not draw any line between x2 and y3. Similarly, we will draw the next rows. This one is 0. 0 means probability of receiving y1 when x3 has been transmitted. x3 has been transmitted, we cannot receive y1 because here it is given 0. The next one represents probability of receiving y2 when x3 has been transmitted. This is 100%. So we will be receiving y2 whenever x3 will be transmitted. This probability is 1. That means 100%. So the next one is probability of receiving y3 when x3 has been transmitted. So this is 0%. So we cannot get y3 when x3 has been transmitted. This means we need not draw any line between them. The next row represents probability of receiving y1 when x4 has been transmitted. That is 0%. So we need not draw any line between y1 and x4. Similarly, this one represents probability of receiving y2 when x4 has been transmitted. y2 when x4 has been transmitted, this is 100%. So it is written by 1. I will draw this channel. Similarly, next 0 represent probability of receiving y3 when x4 has been transmitted. y3 receiving when x4 has been transmitted is 0%. So we need not draw any line between x4 and y3. In the last row, you are able to see probability of receiving y1 is 0. Probability of receiving Y2 is also 0. Probability of receiving Y3 is 100% when X5 has been transmitted. So X5 has been transmitted and 100% chances are there that we will get Y3 at the output. So this is how the deterministic channel looks like. This is always having one element active in every row. So that means each and every input will reach to the output. This means each and every input will reach to the output. So this type of channels are called as deterministic channels. They are having one element active in one row. Now we will move on to the next type of channel, that was noiseless channel. The second type of channels are noiseless channel. So we will have a look at the second type of channel, that is noiseless channel. So I will be drawing the channel matrix for noiseless channel now. Okay.